Hey there, hello there, Sindre here. In this video I want to talk about something very simple. I want to show you how I make diagrams in LaTeX. So when I'm lecturing, I don't really use PowerPoint. I use LaTeX and I make all my figures in LaTeX. So occasionally someone asks, like, hey, your normal distributions looks nice and crispy. Like, how did you do that? Well, glad you asked. Let me show you. So I'm going to jump over here to LaTeX. You can use any kind of compiler. I'm just using a web browser-based one called Overleaf. It is free to use, but you can use whatever. So I have an empty document. There is nothing here except for the preloaded package that comes no matter what you do. So the package that I'm going to use to make my diagrams is called Tikz. So first order of business will be to load that package. So / use package and then TIKC. So Tango India Kilo Zulu. So that is the package. You can put this into like an article or into a presentation slide, like a Beamer presentation slide, doesn't matter. Just to get rid of all the additional noise here, I'm just using document class standalone, so that will just be the figure. So what you do, to start writing code for the figure, you need to have the correct environment. So we're gonna write / begin. Let me just warn you, this is gonna be a bit of a long video, okay? So this is, well, you can see the timeline, how long it is. It's gonna be long. So begin, Tikz picture. And you get this dot there, so you can just click tab here to autocomplete. So the window is just gonna automatically customize to whatever you actually are drawing. So first order of business here is going to be to draw the axis. You can put in a comment here, axis. So let's see, / draw, and you can put in the coordinates here. I'm gonna need 3 coordinates to draw kind of an L to get the y-axis and x-axis. So the elbow here, that's gonna be 0, 0. Dimensions, that is something you need to think about. Quite often I want to put my figures into presentation slides. When you're dealing with presentation slides, like from experience here, I do know that I have about 10 centimeters to work with in width when I'm making figures, and I have 6 centimeters in terms of height to work with. So my dimension here is going to be 0,6. So x-axis value 0 and y-axis value 6. And then that's going to be 1 coordinate. And then I'm going to draw a line to this other coordinate, that's 0, 0. And then to the final one, 10, 0. Now I'm going to put some additional information here, so I'm going to actually add ½ centimeter, but my curves is basically only going to be within 6 centimeters in terms of height and 10 centimeters sort of width. So I'm just going to add here an additional 5. So if I draw this, it doesn't look very nice right now, it's basically just an L here. So I'm going to do something here I want to kind of see the whole thing. It's kind of hidden here behind the edges. So I'm going to draw a rectangle, basically so you can see like everything that I'm doing. I'm going to kind of make the canvas. Like this, let's see, 11, 7, maybe something like that. Yeah, so now we have the box around, so we can see everything that is going on. I don't really like to see the box, I'm just gonna turn the color of the box white. There we go. So this right here is going to be the axis. Doesn't look quite nice right now, as I said, but we can fix that. So if I add the square brackets here, I can specify, maybe make it tick, that helps. And also, let's give this arrows. So stealth. Let's see, my keyboard is in the correct language, as always. Like this. There we go. Yeah, now it's starting to look like something. So our next order of business is going to be to kind of draw the curve. So let's just jump over to Excel and generate some information that we need from there. So here in Excel, basically I want to generate the coordinates for like the normal distribution. So we need some x values and we need some y values. I think 3 standard deviations is going to be sufficient. I'm going to start at 3. Kind of need to decide here on the granularity of your curve, but let's say 0.01. I think that should be sufficient. So if I click Alt F3, I will activate this name box, and I think yeah, 601. There we go. No, this needs to be -3, of course. There we go. So now we have the x values and the y values. So equal here, norm dot distribution. So norm dot dist. I'm gonna take in the x value. Let's see. That's the wrong one. You're gonna need the standard. The norm.s. norm.s distribution. So the normal distribution. We need the set value, which is the x value for us, and it's going to be true because we want the no false. I mean, because we want the probability density function. So this is going to be like the normal distribution. It looks like a bell shape, and if you take true instead, we get the cumulative, so we get the S shape. So like that. To autocomplete this, you can click Control arrow key down, put in a placeholder value like that, Control arrow key up, then Control Shift, tap the arrow key down, click F2, and then click Control Enter to autocomplete it. So that's pretty nice. So let's see what we generated here. We can insert a curve. So yeah, that's how you draw a normal distribution in Excel, by the way. But you want to draw this in LaTeX. So I need to do a little bit more here before I can use this. Okay, right here again, x and y. So first of all, I'm going to shift this to the right. I draw my curve such that it's going to be from coordinate on x value from 0 to 10. I kind of want it to be centered though, so I'm going to add here +5 just to shift it correctly. I can autocomplete again. Yeah, so it goes from 2 to 8, that's good. We can also here write text just to force it to be on the same length. I kind of prefer it that way, not really necessary here. For the y values, here we have a problem because the max value is not going to be particularly high. It's going to be 0.4. Well, my diagram goes from y value 0 to y value 6 or 6.5 to be precise. So what I'm going to do, I'm going to scale this to fit the actual size of my slide or of my diagram. So what I'm going to do, we are going to do as follows, equals here. And it's going to be the y value divided by the max value of all the values here, like this. So then it's going to be in percentage form, and then I'm going to scale it. So the tallest one is going to be 6 centimeters precisely. Good, very good. Okay, so now we almost got it. I'm going to put in text around here to force all of them to be on the same length. Not really necessary, as I said. Let's see, what did I do wrong? I did something wrong. There we go. Okay, so we're almost ready now. So now we just need to do some string concatenation. So basically, I'm going to do like this, equal sign here, then open quotation mark. I'm going to write left parenthesis and quotation mark. And I'm going to use this etco sign. This is to concatenate the different strings. I'm going to concatenate in here the x value, and then concatenate it with something else. It's going to be open quotation mark here, comma, and then end quotation mark, and etco again, the y value, then etco, And then you need the right parentheses, space, hyphen, hyphen, and then a space, and then we end with a quotation mark. Really strange, but it's gonna make sense in a second here. So it's gonna look like this. So this is basically one coordinate and then draw a line to, well, nothing. So we're gonna auto-complete this, like that. Then we're gonna do one more thing here. This one is going to be equal to the one immediately left. The next one is going to be equal to the one above, concatenated with the cell to its left, like this. We jump to the end here, and we can auto-complete. There we go, kind of like that. Let's get rid of that. And now I'm going to copy only the bottom here, so the bottom right cell. So because this one has like all of the coordinates, I'm going to copy this, and then I'm going to jump back over to LaTeX. So here in LaTeX now I can just copy paste it in. So I can write here commenter curve or curve and paste it in. Now it's important here to replace the end here with the semicolon. All of the commands basically in LaTeX needs to be ended by a semicolon. If you do not end that with a semicolon, then the document is not going to compile. It's not going to be like quickly. If you make a mistake here, forget the semicolon, it's going to take you forever before it crashes. It's going to compile forever, and then it crashes. So if you do that, you might as well go and get a cup of coffee. So we need to start by writing draw, and then we get the coordinates and then the semicolon. So if you click now compile, hopefully this will work. Yeah, there you go. There you got it. There is the normal distribution. Pretty nice. But I want to do a little bit more with this. You could end it here if you want to. We have 3 standard deviation, but maybe we should actually have taken 4 or perhaps 5, since I have 10 centimeters to work with here. But I think it's good enough. So what more can we do? We can add a bit of background maybe, add some color and stuff. So I'm gonna write here, draw, let's see, from coordinates 0, 0, not a line this time, but a rectangle. Remember the semicolon, all the way until, let's say, 10.25 and 6.25. And I'm gonna have some background color here. The line itself is going to be gray 20%, and the fill is going to be equal to gray 20%. Yeah, there we go. Starting to look like something. I think my normal curve, I kind of want it to be a little thicker and maybe a different color. I like red and blue. Let's see, let's do red. Yeah, perfect, nice. Okay, so what more can we do? We can kind of get this grid on the background here. I think that is nice. Let's see, so background. Okay, no, let's just call it grid. So for each x in, let's see, 1 all the way to 10. And what I'm gonna do, I'm gonna draw something. I'm going to draw, let's see, it should be a tick, and it should be white. And it's going to be on the x coordinate, and it's going to be from y value 0. And it's going to go all the way to still the x coordinate. I guess my commentary is not really that interesting. I might as well just be mute and just type this out, or even just show you the result. I suppose I could have done that instead, but whatever. 6.25. Let's do that. Now we have kind of half of the grid. Very nice. So I'm just going to copy paste this. So this is a for each loop. So I'm going to draw a line here, and I'm just substituting in different values here of x. So it's drawing this line. The loop is drawing different lines here. Instead of hard coding the value of the x axis here, I just have it here as the loop. So for each y, in not 1 to 10, but 1 to 6, because we don't only have 6 centimeters to work with there. So it's going to be the y coordinate, and the x value is going to go from 0 all the way to 10.25, like that. Perfect. So So that's the background grid. I suppose you can also put some color inside of the here if you want. Let's see, fill equals red maybe. You could do that. Maybe that's a bit too much. Maybe we can put in some opacity here. Let's see, 0.5 maybe. Let's see how that works. So you can kind of customize it a little bit as you want. Yeah, that looks kind of good. Yeah, now I kind of regret that I ended it here at your plus minus 3 standard deviations. It kind of looks like kind of you know, floating, levitating above the axis there. I guess that is fine. I'm not gonna fix that. What else can we do? We need some axis titles. Some axis titles. So backslash node at which coordinate. Let's do the x-axis title first. So at the middle there, so 5 then. That's a -1. Curly brackets, semicolon. We can make the text bold. So I don't know, what has a normal distribution? IQ has a normal distribution, so you can write in here maybe. So this is going to be IQ, for instance. Maybe that's too much to go -1, so let's go half instead. And then we need a y-axis title, so node at, let's see, y value in the middle, so 3 then. -0.5, and this could be like the density. Did I spell that right? Density. This is not going to work because it's going to look terrible like that. So we need to rotate it. So I'm going to write in here rotate equals 90. So let's see. There we go. Much better. Much better. What else can I do? I can put in some ticks here on the axis. I can do that. So axis ticks. So how to do that? I'm going to use the same code for each code. I'm just going to copy paste that down because it's going to be the same thing really. Except it's not going to be thick and white. It's just going to be you know, normal and black, so just the default, so I don't need to write anything. But it's not going to go from 0 to 6.35, where it's going to go from 0.10 to -0.10. And this one here is going to go from -0.10 to positive 0.10. So if I do that, let's see what we get. Yeah, there we go. Very nice, very nice. So perhaps one last thing we can do here is to add some kind of labels here on the ticks. Let's do that. Let's see, axis labels. So node, if I can spell node at, let's see, 1, -0.5 maybe. Well, that's gonna crash with my title over there. So I guess we need to fix that. So that could be, let's see, how should I do that? Minus, what's that going to be? So 1, 2, 3, 4, so -4 sigma. Let's see how that will look. No, that looks nice. So I'm just going to copy paste this. 1, 2, 3, 4, 5, 6, 7, 8. Is that sufficient? So this one is just hardcore, so maybe it would be better if I did this as a loop, now that I think about it. But I'm kind of committed now, so we'll just keep doing what I'm doing. So 3, 2, 1, and then this would be not sigma anymore, but mu. And this would be 1, 2, 3, 4. Let's see how that works. And it's gonna crash in there, yeah. We need one more, it seems. One more we need. 5 and 10. And let's change the axis title. Let's put it back to -1. Perfect. So yeah, that's basically it. That's how you can draw a normal distribution in LaTeX using the Tikz package. Now there's one more thing I wanted to show. You can compile this and you get like a PDF, but what if you want to put this inside of a Word document for whatever reason, which I think is kind of strange. So you can actually extract this as a PNG. So let me just show you how to do that. First I just need to find the snippet of code that I don't remember by heart. Okay, so what you do, you need to open this. We need to click here, upload, and new file. Alright, LaTeX mkrc, and then get rid of this .tex part, and click create. And then I'm gonna paste in a snippet of code here, whatever that is. Then I'm gonna compile, and then nothing is gonna happen. It's just gonna be exactly the same. Very nice. But then now click here on log and output files. So yeah, this is specifically for Overleaf. You can click here on other logs and files, and now you can download it as a PNG. So this option wasn't there before. So this option is gonna appear because we made this LaTeX mkrc and put in that snippet of code. So now you can get it as a PNG additionally. So you can put it in an email or in a Word document or whatever. So yeah, that's it. That's how I make diagrams and figures in LaTeX for my presentation slides. So I hope you found that interesting and useful. So let me just finally say here, okay, was it really worth it to do all this effort? Kind of up to you to decide. For me, I find it very soothing to relax and sit there and drink a cup of tea and write LaTeX also. For me, it's well worth the time. I forgot to mention one thing, and that has to do with the size of the diagram. What if it's too big? Is there a way to make it smaller without having to go in here and change all the numbers, because we had to hard code a lot of the size here? Luckily there is. So at the end of the line, where we say begin Tikz picture, we can write square brackets, and then we can write scale, for instance, 90%, comma, every node /.style equals, and then scale again. So this snippet of code you can add in order to change the size. So you can scale it down to 90%, you can scale it down to, for instance, to 50% or whatever you want. Nothing's going to happen here because this is a standalone, so it's going to always be show the same size here. But if it was inside a document, like an A4 page, then you can change the size. So let me just scroll through the code here so you can see the whole thing. So that's it.